Okay, good morning, friends. Welcome to the wonderful world of trigonometry. I hope you enjoy it. We're going to be going over homework. Go ahead and get that in there. That's important. Please make sure your comp book does designate homework versus classwork. So this is homework 8.3, part 1. And so we're going to go over some definitions and a couple of the questions here from today's homework. So nice thing, only one definition. We just need to know what an inverse trig function is. Now, an inverse trig function is simply the, a couple ways we could say it. It is the opposite of a trig function. That's what inverse is, right? Opposite of a trig function. It is used to solve for an angle. We'll be talking about that. Using this is when we need to find the angle within a trig problem. And just as a quick example, so where you have sine, cosine, and tangent, the inverse function is then, well, it looks like this: sine of -1, cosine of -1, tangent of -1. Okay, and while that seems mysterious, all that really is basically how you have, when you have something like, when you add 3, the opposite of adding 3 is subtracting 3. When you're doing multiplication times 5, the opposite of that would be dividing by 5. When you have 7 squared, the inverse, I keep saying opposite, inverse, same thing, the inverse of that would be square root of 7. Okay, so these are all inverse operations, and that's what inverse sine, inverse cosine, inverse tangent is. In the previous lesson, we were just plugging numbers into sine, cosine, and tangent and finding the ratio. In fact, let me go ahead and write that, where you would have something like, if we have like sine of A equals 1 over 2, you might have a ratio like that. We would plug in an angle and we'd get 1 over 2. If you put sine of some number, you get that long, decimally irrational number. What these will allow you to do, these right here, the inverse function, is I could solve a problem like this. If I know the ratio ahead of time, then I can solve for the angle. That's what I mean by this. This is really the key idea of what we're using these for. We're going to use it to find the angle. So if I have sine of something, this is my variable here, I can use the inverse function on my calculator, and I'll show you that in just a second, to find what this angle would be. Or just say I had cosine of some angle is equal to 0.3758. Again, it's just some long decimally thing. I can plug this in and I can kind of work backwards to solve for my angle. That's what all these other things, they allow you to work backwards because it's the opposite function. So that's what inverse sine, cosine, and tangent are. So that takes us to our first question here. Let me wake up my computer so I can see what that question is. What feature on your calculator do you have to use to solve angles using trig ratios? So I'll even just take this example. I've already written it. You're going to use your inverse trig button. Okay, and where that is, you can take my calculator. We will focus and not get too reflected as much as possible. You're going to need to go to your more scientific version, so you can actually have your trig button. So here's my cosine button. And right now, in order to solve it, I would need to know my angle. Well, actually, let's go ahead and use a simple example. We'll do cosine of 60 degrees is 0.5. So we know that. So I can plug in, I can take my cosine, and if I know the angle, I get the ratio. That's the ratio, 1 to 2. What the inverse button allows me to do is to go in the other direction. So let's just find my second feature. Now all of a sudden, if you can see that, all my tangent, cosine have the little -1 now. So now all of a sudden I've got this. It's also written at, wait, let's make sure I hit the right button. Okay, it might also show up as like a cosine, but you can see the button says to the -1. So now if I were to put 60 degrees into this, I'm going to get a really strange answer. In fact, it doesn't even let me do the calculation. Let's make sure we're doing this right. Whereas now, if I was to take the same problem, let me show you here. So like you have sine of A, oh, we're doing cosine. Cosine of A equals 1/2, and you were trying to find that angle. Again, what we could do is, yesterday we were doing this. We were saying, oh yeah, cosine of 60 degrees equals, you know, what? And we solve that, and we figure out, oh, that's 1/2. So you're heading in this direction. What happens if I need to solve it in this direction and find A? Well, you'll see that's what the button does here. If I do inverse cosine of 60 degrees, oops, I'm in trouble hitting these little buttons. Inverse cosine of 60 degrees, I hit equal. Whoop. Calculator not being helpful. My equal sign is just a second ago. Let's see here. Technical difficulties. Okay, well, something wrong with my calculator there. But you will be able to hit the inverse cosine of, oh, that's what it was. I'm going backwards. I'm trying to put in the angle. See, thank you, calculator. You're making my point. When you use inverse cosine, sorry, it's a little early, making this video early in the morning. 0.5, so what does the degrees for the 0.5 ratio? It comes up as 60. So in other words, it worked backwards. I was trying to put in inverse cosine of 60. That doesn't work. That's too big. There's no ratio that big. So when I had to put in inverse cosine of 0.5, it told me, oh yeah, 60 degrees corresponds with that. So again, we're going to use your inverse trig button, and you'll notice if you try to put in too big of a number for inverse cosine, like I was trying to input 60, it will not even work, because what should go in is a small kind of decimal-y number. So again, when you're working this way with these, you already have the ratio, and the inverse button will allow you to find A. There's a quick way of what that would look like, just continuing, is you would have, say you had, it's kind of like you had cosine of something equals 1/2, and what you're doing is you're basically taking the inverse cosine of both sides. Okay, and so what that does, just like when you do algebra, that cancels out on this side, and you just get A equals the inverse cosine of 1/2. And that's what I needed to put in my calculator, because then I do this, and that's when I get 60 degrees here. This is just, I keep using 1/2 as an example. So again, it's just like when you would work backwards in another type of algebra problem. It's the opposite operation. Okay, so question number 2 asks us, computer keeps going to sleep, when do you use sine, cosine, or tangent, and when do you use inverse sine, inverse cosine, inverse tangent? Well, when you have these, you are solving for the ratio. So that means you have something like tangent of 45 equals, and I don't know the ratio. Or maybe I know cosine of 60 equals x over 4. So another way of saying this is if you would use this if you already have the angle. If I already have the angle, I'm going to use what we did in 8.2, sine, cosine, and tangent. we're going to be using the inverse today when you need to find the angle. So, same situation, tangent of it'll be x, or I'll just say tangent of b, some angle, is equal to, and then we know the ratio, 3/5. Or we know it's cosine of a equals 0.3582. And then it's the inverse button that's going to allow me to take this ratio and find the missing angle. So that's what you use the inverse button for. So let's go ahead, and I'm going to end this video now, and we'll get to the questions 4, 8, and 14 in the part 2.